Hello, everyone. Thank you. Thank you once again for taking time to be part of this discussion. And today we'll be talking about magnesium alloys. And as you may know, it has several advantages, including low density, high specific strength, a high degree of biocompatibility. I got it right. It is also excellent ductility and malleability. However, it has some downsides, which has to do with it's prone to corrosion and low flammability and easy ignition. I think these are very complex words. What we'll try to do is to make it very simple for our viewers to understand and follow the importance and significance of MG alloys to sports. The automobile, aerospace, and aviation industries have found widespread applications for magnesium alloys. What about the sports industry? We know some sports equipment have or contain magnesium alloys, but little have been said about its relevance. Today, what we'll be doing is to discuss the relevance of MG alloy in the sports industry. And we believe that ultimately this will provide students and listeners with an excellent opportunity for experiential and empirical learning. So today we have a guest. I would not say much about the guest, but what I would say is that he's an assistant professor at the Iranian Research Organization for Science and Technology, and his PhD focus on material science and engineering. So I guess that this is going to be very interesting for those who wants to learn more about MG alloys and its significance to sports. So to begin with, I would like to know who our guest is. I may have known him, but he will tell us a little bit about himself, his academic credentials, and what his research interests are. And basically, this is intended to create or to share knowledge to all our listeners, students, and those interested. So over to you. My guest, I don't want to mention the name. He will mention his name. Yeah.
Yeah, hello Drake, and hello to everyone who are listening to our talk. My name is Ahmad Mg Bahmani. As Derek said, that I worked on the magnesium alloy. Basically, I can say it's a part of material science and engineering. That I don't know how much I can say, but I started in Iranian universities like Sharif University. Then I moved to South Korea, and for 2 to 6 years, I was there. And I can say that it's about 10 years from 2013 that I focused a lot on the magnesium and magnesium alloys. It's part of light alloys, and that is why and magnesium is the lightest structural metal between light metals or light alloys. The other ones are aluminum and titanium. If you want to know that with which materials we should compare, these are the best candidates: titanium and aluminum. And we call it magnesium and the lightest structural material. And I don't know what exactly more should I say, but
Yeah.
introduction was enough, or maybe I should say for the person.
Well, I think that's perfect. So I mean, just to let our viewers, especially the students, and then all our listeners know that we're coming to talk about. We're not just coming to speak, but you have the expertise, you have the experience, and also you have the you know what it is in terms of empirical analysis and about MG alloys as well. And I mean, just to tease my viewers and students out there, Ahmed has come up with some interesting findings with regards to MG alloys and its significance to the sports industry. But just to begin with, I know a lot of people will be asking, what is MG alloys? And what's the meaning of magnesium? And It's usually in short MG alloy. So I would ask Ahmed to give us a short presentation about what MG alloy is. I think this is going to be very brief, so you have an understanding of what we're talking about. So over to you, Ahmed.
Okay, thank you very much. Then I'll share my screen here, and I made the presentation in a PPT file, and I hope you have it now.
Yes, that's perfect.
Okay. Magnesium in the sport industry. I just made some of the presentation, some of the slides here. It would be a little, and I hope that if you have other questions, please ask Derek or maybe directly from me, that I can answer, and it would be really my pleasure to answer this question, and maybe we can update or opinions about the industry or science of magnesium and its position in the industry and science. First of all, this is the contents of this presentation, introduction to me and magnesium, me and MG. And we will say that magnesium is the lightest structural metal, and it is eco-friendly metal and biocompatible material. And then we go to some applications of this metal that the people already reached, or maybe they focus to reach, and finally a short summary. As you can see, this chassis of our automobile, that two women can really light up, and it's 47 kilograms. This is the more important things about the magnesium that we want. A bit about the background I had. This universities that I studied, three of them were in Iran, and Seoul National University. I got my PhD, and then I moved to IRIS, Iranian Research Organization, and I also found a startup company which is called Art of Magnesium. It's abbreviation of Advanced Research and Technology of Magnesium. But about the magnesium introduction, the first thing that we can say is this example. For example, we can see this is steel, aluminum and magnesium with the same volume. We have it would be the lightest. The density of steel is about 7.8, aluminum is 2.7, and magnesium is 1.7. So it would be much lighter. And the other points that we have is that even though it is very light, it is strong. Between the metals, you can see in the pink color, magnesium is it is located in the left side. This diagram is called Ashby diagram, with a combination of several materials. And interesting point is that we have a wide range of strengths, some more than high strength steels even, and definitely higher strength than structural steels and aluminum and other things. The other point about magnesium is that magnesium is seventh element in the Earth's crust. So the resources is available everywhere. We don't have any limitation about the resources. And the material is biocompatible. We all know for magnesium is very beneficial for human body, and more than 400 reactions in human body, magnesium is collaborating on that. And the other point is magnesium is biodegradable. It will be degraded. It will be coated slowly or fast. It's up to scientists work at how to design the work, but this make it eco-friendly also, because if you put it somewhere, it will be destroyed and it will go back to the nature. So we don't have this problem. it will make a reaction with oxygen, and then it will be removed. Uh, uh, but still, as Derek said at the beginning, there are some problems. We have magnesium is very active. Sometimes you have ignition problems and corrosion problems. This is something that we have on iron also, that it will be corroded very fast. And the magnesium in low temperature, we don't have good formability, and we cannot move, we cannot deform the material easily. And this is the points that scientists and industry should deal with, and to improve the material. That was why the application was limited, and so we try to overcome these problems and make it more useful. I have a diagram here. You can see the production rate of magnesium from 2000 to 2017, and you can see from 157 1,000 tons, the production rate of magnesium has been reached to 1 million ton per year. So this shows that how much it is using in the industry. From a little bit earlier, from 1930, you can see the production rates, and we have a change. We have a in graph when China entered the industry of magnesium and production of magnesium, the rate was suddenly increased. And the first one was World War II. Unfortunately, the rate lighting was important in the war also. That was why the first peak was here, and then China. Other points that we should also deal with is the price, right? The most important competitor for the magnesium is aluminum, and you can see we have there is a competition between magnesium and aluminum. Aluminum is a little bit cheaper, but the rate, I mean the proportion is about 1.3, and that's why the price is another key point to determine how it is useful. Other competitor is titanium. You can see that it is more than maybe 5 times more expensive than magnesium and aluminum. So titanium usage is very limited. That's why. But we can increase the application in different areas. I wanted to make it short, and I know, but this part would be a kind of gallery for some usage of magnesium, and that's why I don't stop here a lot. You can see in automotive industry, different areas like this body structure of GM motors that have been reached to 33% lighter than steel that previously had been used by using magnesium. And electronic devices, aerospace, powertrains were other usage of the magnesium. And another point that could be also very important, I think, for the sport people, because we have a lot of injuries in the sport sections. As you know, we have implants for healing the surgeries. You can see this screw or pins or plugs that can be used in the bones. If some part will have a fracture, then you should fix it, right? The best way, we usually use titanium or stainless steel, but they are permanent. Recently, some companies have started their work by using magnesium alloys here, and you can see here, this is screws. After treating these injuries, they have been removed. right? They were degraded, and because they are useful even for osteogenesis phenomena, they make the new bones easier. They produce the bone generation, and that could be useful. They will be removed. We don't need to have a second surgery here. Another point that we have also issued is that it has an anti-tumoral effect. We had seen after implantation, some cancerous cells were removed and some stem cells without cancer effect has been increased. So this could be a very good perspective for future of cancer in this case of implantation. And this is one electron microscopy of a stem cell that has been touched to or sample, showing that it likes the magnesium. The other application is for the orthopedic applications like canes, wheelchairs, walkers, and other things. It seems because it is lighter than other alloys, it can make easier to move it, and it will give us faster motion even. So that would be very important for us. This is one of the bicycles has used the magnesium frame and wheels. So we can assume that if it will be magnesium, and at least you will have maybe 4 times lighter bicycle, right? Then definitely it would be very important. When you assume the 1 second is very important in the matches or competitions, that would be very important. In other cases like rockets, handles, and especially mountaineering and climbing, the poles and handles would be very useful. And definitely for the cars driving, some sections of these cars and are using magnesium because when you reduce the weight, then you will have a less. You will need less energy, and you will have a faster automobiles also. In para sports, and I think that everywhere you see metals or materials, we can think about that. Definitely because of those problems, we cannot directly go and use it, but we can think about that. If this could be the case, that we can use magnesium to make it cheaper or make it easier for motion. And this is the summary of this presentation. First, we talked about the magnesium advantages and disadvantages, and then finally applications of the material. And that's all. I don't know how long I talked.
I think you should take your time and just keep going on. Don't worry
No,
about
it
the
was
time.
finished.
Oh,
Actually,
it's
it is
finished,
finished.
yeah.
Then we can, yeah, it is finished.
Okay,
I tried
that's
to make it
interesting.
fast. Yeah.
Yeah. So that's it. Just to let our viewers once again know, this is a presentation of magnesium alloy. Its relevance to the sports industry, I think, has been covered. And I think what you have to know is the usefulness of the magnesium alloy, which has already, as Ahmed said, it's been useful since ages. But in terms of the sport industry and application, let's say application in the sports industry, how do you see Mg alloy? What's the significance? What would it change in terms of the sports industry based on and your research over the years?
Yeah, thank you. Actually, I think that about the sport, you should think in two cases. One of the cases is that all the maybe 3 points. First is the viewpoint of the doctors because they for bone generation and for body health of our body. We need magnesium, and you have seen they use magnesium, zinc, calcium tablets, right? It shows that how it is important. This is one case. But for the focus of my work, I usually use the magnesium like this one. For example, this is a pipe or different shapes.
Is it possible to unshare the screen so that it can be
Okay.
visible? Yeah.
Yes. Yeah.
Yes.
For different sections or different materials that we use, I think that in different sports, for example, just imagine a climber or mountaineer that want to hike in a long distance or very difficult situation. You know that even 1 kilograms or 1 grams is important for him or her, and they want to have a lighter bag, lighter devices, and something like this. Then, if we can reduce those weights without changing the ability for motion, like for example, trekking poles, right? I think that this is very simple. It's kind of pipe like this, right?
Yeah.
Then we just change it with steel or aluminum. That usually the aluminum is being used here. Then lighter material you will have. In the automotive industry, in Formula One, I have seen by my eyes that several parts are using magnesium because this is how can I say the final limitation they have. They want to be fast as much as possible. So reducing 1 kilogram, 1 grams would be very important. Then for this device, for the automobiles, motorbikes, bicycles, and this was the second viewpoint, and I think that the third one would be the surgery. When people have injuries, you know you are you were you know athletes more than me, and you as I saw, always they have these problems, surgeries problems, and breaking legs and everywhere, and make it better. There are always a lot of problems, like implantation, for example. They have for fracture in their fingers, their hands. They should make an implant, and after 1 year or 2 years, they should remove it, and still they have those problems, right?
Yeah.
But with this, we can solve this problem just one time, and
Results, yeah.
Yeah, it's over.
I mean, just to add, I remember I had a surgery when we were in Korea on my knee because I used to play football. So one of the metals, I think it's magnesium alloy, was inserted in one part of it of my knee, which dissolved after some time. So now I don't have a problem with regards to what's over there. So I truly understand what you're talking about in terms of its biocompatibility in terms of injuries in sports and what have you. But let me ask you, showed us a sample of your magnesium alloy. I know people know what magnesium is, but don't really understand when they say alloy, because magnesium alone cannot solve the problem unless it has the alloy, which is a component or mixture of different, should I say metals and different components. Yeah, so with yours, I know some people use the zinc, others use the aluminium, and there have been, issues about its corrosive nature, but it can be reduced based on what is contained in the alloy. So with yours, what exactly is in the alloy that makes the entire magnesium alloy perfect for the sports industry?
So let me say something first, that We have metals and we have alloys, right?
Yeah.
As you know, metals are pure.
Yeah.
We have a periodic table. Some of them are metals and some non-metals and some semi-metals. Magnesium, aluminum, zinc, all of them are metals. And they have their own properties, but most of them are very they are not strong at all, and they are very soft. Usually, they are soft.
Okay.
But the most important point here is to improving the strengths. The best method for improving the strengths of the material is alloying. Uh, Usually, for magnesium, we add aluminum. The first element that always we think is aluminum. We use aluminum, then, for example, the strength will increase from 50 megapascal to 200 megapascal, like 4 times more. Then it would be very important. And that would be our word to think that why it has an interest, how much it is important, how much percent is important, 5%, 10%, or what? And after that, you need other metals like zinc, like calcium, maybe even trace elements would be very important. Sometimes even 0.1% of some elements like zirconium or manganese is very important, and that will increase the strength, first of all. This is same for most of the metals. But for the magnesium, which is very corrosive, and still we have, or maybe the better example would be stainless steel. We have iron, right? Iron by itself is very soft material. Carbon will be added to iron and the strength will be increased, right? And another metal, which is chromium. Chromium will make it stainless steel. And the price would be increased, but the application would be totally different. For the stainless steel, it will not be corroded because it will make a restriction for corrosion. And here, for magnesium, it is not still well established that which metal is very important for that. But my thesis also was for that to make a stainless magnesium, and I can say that calcium is very important for magnesium alloys, and it should be used even in low amounts. It can help for reduction of the corrosion. Other properties also would be important, right? Permeability or ignition, right? We don't have room temperature formability for magnesium. Elements like aluminum or zinc can help to increase the formability, because if we have a metal like this, we can produce by casting or something like this. But we need to make different shapes. We need to change it, like the shape of this, and we cannot easily do it. So for plasticity, for changing the shape,
is it okay to raise it a little? The camera is not capturing it.
Yes. Yeah.
I think your camera is not.
Sorry,
your camera is not capturing it as you are demonstrating it. Oh yeah,
okay.
yeah.
Yeah.
I think that's perfect.
I should have a better case, maybe thinner. Then it will be broken if I do like this. If I had enough power to make it, it will be broken, not moving. Then I need to make it. I need to put some heating to this metal to deform, right? Other metals, other alloying elements will help in this way. Changing all the properties that we think.
And I think this is very important for especially students and then the viewers to know that and the magnesium alloys has so many components that make it stronger, that make it, like I saw in one of your research, specific strength. So based on the particular sport, it can be made to fit that sport. So I think it's important to know that sometimes so many properties and or what you mentioned elements are kind of like used to ensure that specificity. So there's calcium, you mentioned chromium, you mentioned zinc, you mentioned a little bit of iron, and that's used in different ways based on what equipment will be used. And I think this is important because I remember some days back when we wear our football boots, it was made up of, I think, strong steel or sometimes metals. It makes it very heavy for athletes to run. We can also talk about the track and field athletes, those who wear the spikes. It could be improved with a magnesium alloy to make it a little bit lighter for them to go about their business. So I think what you mentioned is it makes a lot of sense so far as the sports industry is concerned. But if I may ask you, and I know there are so many sports out there. I know a little bit about Iran in terms of, I know they play football, they play all kinds of sports, climbing, and what have you. If I ask you specifically, based on your experience, both as an academic and then an expert, and with your knowledge in magnesium alloy, what type of sport equipment or sport good would you specifically, if given the chance, want to work on with in terms of improve that sports equipment with magnesium alloy?
Uh, it's not very specific things that I thought about it, but I planned personally. I plan to. Uh, I've seen bicycles totally
Yeah,
made by magnesium. I've seen automobiles that several parts of them have been used by magnesium. But the things that I'm interested, because I'm sometimes I do my mountaineering and I have some friends with this trekking poles and canes, right? That's why I made this pipes
yeah,
for them. Then for this, I'm pretty sure it is very useful, and it's not very difficult to make.
yeah.
It's called extrusion of the pipes, and when you have different sections, you can just make a telescope on them, and then you can make it. And as I saw, I think that maintaining, because as I said, that all the grams are very important, and I've seen that they even sometimes they buy carbon fiber based and also titanium based one. It will make cheaper, but they are very expensive. Comparing to that one with the magnesium, and I'm pretty sure that we can achieve the same or even higher properties. Um, then I've seen also about the handles of golf and tennis, but there are some papers on them, but I don't know exactly the details of them that if it has been gone to industry or not. Yeah.
But in terms of sports, sports has a lot of standards, and
Mm.
there are issues about doping. In terms of standards, how do you think the sports industry would embrace magnesium alloy? Would it make people, let's say, in track and field run faster? Or those in bicycle, those in the cycling events, would it make them to run faster than their colleagues? How do you foresee magnesium alloy, being accepted in the sports industry in a way that it does not improve people's records or break already existing records?
I don't know how to say if I understood your question completely. You said that there are several standards, and they are
Yeah,
always monitoring the athletes, how their work and
yeah,
how they have improved their things.
yeah,
As you know, that all the devices that they have used from the years has been improved.
yeah,
Uh, and we don't do anything by their body. We just making their devices better, their tools better. Or maybe if maybe you can for the from mechanical viewpoint, if you for the frame of bicycle, if you remove some parts, then definitely it will be lighter. But you didn't do anything by the I think that anything by the doping problem, right? It's just made it, and we just changed those materials. Uh, I mean, that for the surgery case and implantation, it is something that definitely should be done by the doctors. Uh, I don't know exactly if the dose of some materials will be increased if they are problematic for the healing, but I mean that there are sports and standards, but I know that the doctors should prescribed for using this one. And I think that for this surgery, they cannot, I don't know exactly. But for the main things that we want to do is the devices and tools. And as far as I know, they don't have that much to deal with the standards.
Yeah. Yeah,
They're always trying to make better engines for their cars, or maybe better um, aerodynamic for their machines, for their even airplanes, driving faster or better. And it would be one of them, maybe not that much strong change suddenly, maybe a little bit.
Yeah, that's super true. I totally understand. And I agree with you when you said to make the equipment more durable and strengthen its capacity and capabilities, which is very important in sports and in the automobile, and then the in terms of the its biocompatibility and injuries. That's fantastic, and I think we've seen its relevance. But when it comes to sports, you know, people are always talking about records. People are always talking about so others having competitive advantage because of some equipment. We saw what happened in I think the Beijing 2008 with the swimsuits, you know, breaking almost all records. So I kind of like looking at it from where I sit as a sport management person, and I'm looking at the passing through a kind of standard and to ensure that people are using the right and then a balanced equipment whatsoever. So I believe that it would have to do with cooperation with the sport industry, whichever international
Exactly.
federation, and then passing through that. And I know this happens a lot. And I also agree with you when you mentioned that um, certain components, especially with automobile, and as well as the aviation and then the aerospace as well, they try to improve their various properties that they use in building their products. And the same with sports. So it's more of a collaboration with the sports industry. So
Yeah.
basically, I think it's been fantastic conversation, a very brief one, and an eye opener for those who do not know what goes into the sport equipment that we wear. A lot goes into it, and there are people like Ahmed that works on these areas to improve the kind of sports equipment the sports equipment we use, and what have you. I'm not sure if we've exhausted everything, but do you have any other thing to add to the discussion so far? I think it's an interesting and unique one. Yeah.
Yeah, about the other points that actually, I don't know if that is how to say, but I just from the years ago, I just saw that there is something that it is useful, and there are many challenges. It could be interesting for the future of our world, and that's that's why I say that it's interesting for me. Then
Yeah.
I worked. I didn't have any plan to make it bigger. That time, my professor was decided and forced me to work on this. And then after I made, I became free of my PhD. I said that then there are a lot of things. Then I always think about that. Everything that I say, that everyone that I see, I'm talking about this and the advantages, disadvantages, problems, and I'm trying always to make an interactive situation with them and make interactive discussion with them and trying to improve them. That would be the thing. I felt that my work is my loved work, right? Then I'm just doing everything for that. And other things that I wanted to say, we said about the standards. It is same, not exactly the same, but the process would be same for other industries. Like for automotives, they usually say that we want the material with these properties, like strength should be get this one, and corrosion will should be this one, and the weight would be this one, and it would be cheap. That's finally. And we are all thinking that which material, which composition, which process can make this one best. And then we have to go to analysis centers and reference centers and ask them to make analysis, make a test for materials. And we will prepare a lot of references for the industry. And we say, these are the case, and we try to make a point. And for the industries, I know that they have their own limitations and the restriction. They don't want to change. Just in the case they have to force, they have to change. That's why we just propose a material, and we ask if you need, we have this one. You can think about it. For the people, also for the students, for the industries, other ones, if they have idea, I would be very happy to discuss. And maybe in future we can find the solution for the problem.
Yep, so maybe in future we can find solutions to improve and strengthen sport equipments as we've discussed.
Exactly.
And today we've had a very wonderful discussion and with my guest, Ahmad Bahmani. I tried to pronounce it very well, maybe not in a very passionate way, but I try my best to get it right. And if you want to know more about what Ahmed does, I'll share with you. And as you see on the screen, it would be his profile. He's written extensively on magnesium alloy, its usefulness, not only to the material science world, but also to various industries, in terms of sports, in terms of aerospace, in terms of biocompatibility, as I mentioned earlier on. And I believe that this is also an indication that sport is not static. It's not only sport management. It's not only sport science. It's not only sport marketing, but it encompasses all these areas, including material science and engineering. All these areas come together to make sports enjoyable, to make our equipment easy to wear, and also to make it durable so we don't spend too much money on it. And on that note, I want to say thank you so much. I really enjoyed this one. It's quite different from the rest I've done. And I want to thank you for your time. I really appreciate it.
Thank you very much. Same here. It was really interesting talk with you after a long time, and there are many challenges was open for me, and I know that after this discussion I will go and check, especially about the lenses that you said, and other sections of the sport industry, and it would be really it was a really good discussion for me also, and I hope all people reach us later also for these questions. And
definitely. Okay, then. So we meet again.
Okay. Goodbye.